One of the wireless technologies that has seen considerable attention in the past few years has been a technology called Bluetooth. Bluetooth itself has actually been around for quite some time, but only in one of its most recent revisions, Bluetooth LE, or what's known as Bluetooth 4.0, has it really started to catch on. Whether you have experienced the joy of trying to pair something with Bluetooth or have a recently purchased health sensor that uses Bluetooth, the goal of this module is to help you understand how Bluetooth works and its primary roles. Bluetooth was originally proposed to meet the needs of timely, reasonable speed communications over relatively short distances. While protocols that focused on infrared, such as ERDA, offered some data connectivity, the ability to work in an omnidirectional or any direction manner without line-of-sight constraints was highly appealing. Oh, and Bluetooth needed to be low cost and low energy too, because we wanted to put it in very small devices. To help keep things simpler, Bluetooth chose to operate in the 2.4 GHz band, the same spectrum bands as Wi-Fi. Recall that the 2.4 GHz band is unlicensed. The devices simply need to play nice together in order to work in that band. Unlike Wi-Fi though, Bluetooth aimed to offer a degree of timeliness or a degree of predictability when data might be delivered. Hence, while Bluetooth operates in an unlicensed band, devices actually pair with one another and join a network, with one device being marked as the master that controls the channel and the other devices being marked as slaves who take their marching orders from the master. Now, with that particular network having one device as the master, channel access for the devices working together is done in what is called a piconet, and it becomes reasonably controllable and predictable, subject to the vagaries of the wireless channel. For applications that need timeliness as to when data needs to be sent and delivered, such as a headset, this type of control is essential. Bluetooth offered a variety of speeds and ranges that could be configured by the hardware designer. Numerous exchange protocols would also allow devices to talk to one another and discover nearby services that in theory could create a virtual sandbox for designers to compose wonderful services across the utopian Bluetooth landscape. If you did not detect the sarcasm in that last expression, the reality is actually Bluetooth has been quite a bit uglier. While composable services can be quite neat, the problem is that I, as a user, typically only want to compose my own devices, not let anyone else take my data from my devices as they see fit. Hence, a key component for Bluetooth has been the notion of security, and that a device would need to enter a PIN code in order to allow access to its data and to ensure proper and secure bonding. However, if you think about a typical Bluetooth device, they usually don't have a keyboard. It's an earpiece or it's an audio system for your car. So conveying somehow what the PIN code should be quickly turned into a nightmare. Beyond figuring out how to communicate what the PIN code is, quite often the PIN code would not work due to odd, esoteric, or weird reasons, leaving users often frustrated and angry. Industry quickly realized that one or two different keys work best. Think about all the devices that tell you to enter a password of 0000 or 1234. Not exactly the most secure. Couple that with the fact that Bluetooth came in over budget, each chip cost far more than expected, and far less power efficient than expected. For years, Bluetooth was viewed as a failure, despite significant industrial investment. With the rise of several of the later Bluetooth variants, and in particular the most recent Bluetooth variant called Bluetooth LE or Bluetooth 4.0, things seem now to have finally turned the corner. First, the Bluetooth chips now are finally approaching appropriate cost and energy consumption. Second, and perhaps most exciting, Bluetooth LE devices introduced the notion of a one-way advertisement, whereby pairing and security no longer became necessary. You might have heard of one of these variants, called the iBeacon. The gist of the iBeacon is very simple. Use the shorter range of Bluetooth to pin down co-location or proximity of people and devices. By removing the need to pair, but only conveying a limited subset of information that you don't mind making public, a sensor then can now quickly be linked up with other devices. So if you think about it, what ends up happening is the short range keeps it in range of only a few other devices. It might be a treadmill, say at the rec center. Alternatively, a store might scatter hundreds of these beacons throughout, and then write an app that recognizes these beacons. For instance, if you say linger around a department store display, it might push you an ad to encourage you to buy something during that critical period where you make up your mind. While this is terribly fascinating, keep in mind too that your detection of beacons, or acting as a beacon yourself, means that now you're possibly being tracked, which has significant privacy implications as well.